Okay. I don't know why that makes me smile. It just is so like, I don't know, weird. So let's start with yesterday we started 8.9, which was solving these nonlinear inequalities, which we haven't actually solved them yet. That's what we're going to do today. But the first thing is you have to be able to identify when you have a nonlinear inequality. And I guarantee you will come back to this again and again and again. I have students in 1800 that still like miss it. So let's go through these. Okay, part A, linear or nonlinear? Anybody want to take a guess? You can put it in the chat too if you don't want to say it out loud. How about this? Okay, let's do some interactive class time here. Interactive time. If you think that it is non-linear, give me a thumbs up. Non-linear. If you think this is non-linear. If you think it's linear, let's see, what are my reactions? Let's just do non-linear and nothing. All right. Okay, I got some thumbs up saying yes, it is non-linear. Okay, that would be correct. This is non-linear. And the part that gives it away is the variable in the denominator, okay? So the fact that you have a variable in the denominator means that this is a rational function and it is nonlinear, okay? All right, so what about part B? Linear or nonlinear? Thumbs up if you think this is nonlinear. Thumbs up if you think it's nonlinear. Oh, very good. And I just like, oh, I didn't catch anyone. All right, good. Yes, this is linear. Okay, which we could solve it, isolate x right now. There's no problems. Okay, x is to the first power. There's no weird stuff with the variable. It's just, I don't know, looks normal almost, right? All right, look at part C. Okay, thumbs up if you think it's non-linear. Nader says yes. Everyone else is not. Nija says yes. Emma says yes. Nora says yes. Sydney, oh, okay. You would be correct. This is non-linear. Okay. So that variable inside the root is what makes that non-linear. Okay. All right. Part D. Ready? Linear or non-linear? Give me a thumbs up if you think it's non-linear. If you're paying attention, you should know this for sure. All right. Getting some thumbs up. Okay, this is similar to part A, isn't it? Isn't it? We have a variable in the denominator. Okay, this one's not. The 5 is a number, but this variable means that this is nonlinear. And you understand that when we graph this, what I mean by nonlinear is your graph is not going to be a straight line. Okay. All right, let's look at E. Linear or nonlinear? Give me a thumbs up if you think it is nonlinear.
I have a question real quick.
Yes.
Why is C nonlinear? I didn't catch it, sorry.
Because there's an x in the denominator. You see the variable? So x minus 1 over 5 is fine. That if that were the only part.
I was talking about C.
Oh, C, I'm sorry. Yeah, you did say C. Because there's a variable inside of the root, okay? The root makes this a nonlinear inequality. If you didn't have the root there, then yeah, it would be linear because that's just x to the first power. Okay. All right. D, nonlinear. Okay, what about E? Give me a thumbs up if you think E is nonlinear. Couple people. All right, some people. If I were to multiply this out, what would be my highest power? Does anybody know? Yes, good, Nader. So if we multiplied out x minus 1 times x minus 5 and then took that and multiplied by x plus 4, you would get a leading term of x to the third because you'll have x times x times x, okay? So that means this is nonlinear, okay? It's going to be a higher power. All right, and then f. Is f linear or nonlinear? Nonlinear, if it's you think nonlinear, thumbs up. Okay, a couple people. You are correct. And what gives it away here? My x squared, okay? The x squared means this is nonlinear. So I only gave you one linear. So just to give you guys an idea of how like many different scenarios we can come up with. So the key idea here is that nonlinear inequalities require a sign chart. To solve, okay? Everybody else, or all the linear ones, we already know how to do that, okay? So nonlinear inequalities require this sign chart thing. So for 5 out of 6, we would need a sign chart. And hopefully, I think I probably do examples today and tomorrow. And then by that point, you would know how to do all of these, okay? All right, let's look at number 2. Now, number 2, I had to squeeze it in there, but I didn't like how close it was. Let's just move this down a little bit. Okay. This was squared like this. So I give you this function called h of x, which is x squared plus 2x minus 3 over x minus 3. And then the top does factor, but it doesn't simplify. And what you should notice is if you look here, this 3 and -1 correspond to your x-intercepts, okay? So when we do these in a few minutes, you're going to see that factoring is important to get your x-intercepts, okay? All right, so let's look at this. Now remember the sign chart, okay, so recall the sign chart does what? What do we use this thing for?
To see where values are positive and where some certain values are negative.
Yeah, the sign chart records, all it does is record the signs of the outputs. Okay, in other words, the y values, okay, of the function. It tells us which intervals of the inputs produce negative outputs, negative or positive outputs. Okay. So, because that's key, because really your answer is the interval of inputs that produce these outputs, okay? So your sign chart should always mimic the x-axis, okay? So wherever you see something happening on this x-axis, even here, it has to go on your sign chart. So this 3, this -3, I'm just gonna drop it down in this 1, okay? So these are my zeros, the zeros of my sign chart. And then this 3, now what does an asymptote mean on a graph? Anybody remember, what does that tell us? What information? Everybody's like, I don't know, we blocked that part out. A vertical asymptote tells you that, okay, thank you for your honesty, Cornelius. Tells us that, tells us which numbers are not in your domain. Yes, good, Amarian. Which numbers are not in the domain, i.e. undefined. Okay. So that also goes on our sign chart, and I'm going to leave it as an open circle, and I'm going to call this a bad number. Some instructors put a U for undefined, and that's fine. I just like to be dramatic a little bit here. I'm in general a no drama person, but I'm gonna be a little dramatic here. This is a bad number. It doesn't go into my function, okay? Also, it means there's no output at x equals 3. You guys see that? This graph is gonna approach the asymptote. This graph is gonna approach the asymptote, but it is never gonna cross it. So no matter how far up that asymptote I go or how far down, I will never actually touch the graph. That's what that means, okay? So on my sign chart goes my zeros and my bad numbers or undefines. Okay, now let's do some recording. From this is one interval. So this is one section, 2 sections, 3 sections, 4 sections. So I have 4 sections to record. In between each of these, I have to tell whether or not my input or my outputs are positive or negative. So before -3, what's my function doing? Is that positive or negative?
Negative.
Negative.
Negative. See, all of my outputs here are below, I'm below the x-axis. So this means they are negative. Okay, so I'm going to put negative here. All right, now what about from this section here, from -3 to 1? That's all these outputs here.
Positive.
Positive. Okay, we'll put it in green just because. Okay. Now, what about from here to the asymptote?
Negative.
It's negative. Ooh, let me use my red. And after, here's everything after.
Positive.
Positive. It's above. Okay. So this would be your correct sign chart for this one. If you had this, you got it 100% correct. But probably you weren't sure what to do with that asymptote because I haven't talked about it, but I wanted you to at least think about it before we talked about it. Any questions?
Yeah, I have a question. Do we have to indicate the zeros?
Yes. You have to indicate the zeros and any undefines. And then I would not put any other numbers on that number line, okay? And you'll see why. You want to keep it very simple. Otherwise, you end up doing more work than you need to, okay? All right, so now one more thing I want to ask you. If this question asks, so now let's interpret the sign chart. Let's look at this. So for A, I want to know, and it would look like this. The problem would look like this. Solve when I'm just going to put, I'll write the whole function. You guys probably like that better. X squared plus 2x minus 3 over x minus 3. This is the function. Tell me where this is greater than 0. And part B, I would want to know where the function is less than or equal to 0. So take a minute on your own and see if you can record those intervals correctly. I worked out this morning and I'm like still hot. I like go between hot and then I get cold. I'm not sick, I promise. Okay, does anybody want to take a guess on A? What intervals did you put for A here? You really only need to look at this number line, not the graph. I should have emphasized that. Let me call on somebody. Ooh, that's so scary, isn't it? Thank you, Cornelius. All right, how about Miss Sydney? I miss you, Sydney. I don't get to see you all anymore. Do you have the answer for when it's greater than 0? Do you want to take a shot?
No.
All right, so here's the other way to ask that question. Where is the function positive? Which intervals?
Is it 1 to 3 or no, -3 to 1 and 3 to, is that infinity?
Yes, very good. Okay, those are the intervals. Now let's make sure we get the correct brackets. Is -3 included?
Yes.
Okay, it looks like it according to the chart because I made it a black dot, right?
Oh, yeah.
But look at the inequality. Are zeros included?
Oh, no.
No. Okay, so I don't include it because of the inequality. So just that's the extra thing that makes that a little bit harder. Okay, so zeros are not included. Now you go to 1 and it's not included, right? I'm going to union. Now, what about the bad number 3? Do we include this?
No.
No. Never include bad numbers ever. Okay. So we never include that one. So that would be when it's positive. All right, let's try. Thank you, Sydney. Thanks for sticking that through. How about Michael? How about part B, Michael? Do you think you can tell us when this is going to be less than or equal to 0, the function? Another way of saying that this less than or equal to 0 is basically saying when are the outputs negative. Okay, less than 0 means negative. Or in this case, 0, because you have the equals. Okay.
So 0 can be included in this one?
Yes, because of the inequality sign. All right, so Michael, do you want to try it or you want to pass?
When they are low -3 and yeah, that's it. Low -3.
Where it's 0? What about where it's negative? Where are my outputs negative? Look at the sign chart there.
When it's below 1.
Do you see this where I put the
Between 1 and 3.
Do you see these red zones?
Yeah.
That's the interval where the outputs are negative. So that's going all the way from out here, which is negative infinity, to
3. -3.
Okay. So it's going to
In
be
between.
negative. And since it's equal to, I can include it. And then what's the other interval?
Union square bracket 1 and 3.
Do I include the 3?
No.
No, because it's a bad number. Okay. So very good, Michael. Thank you for sticking that through. So you see on the second interval, 1 is included. So both your zeros are included, but not 3 because this is a bad number. This is undefined. It doesn't matter if it says equal to, you cannot include it. Okay, any questions on that? So interpreting, you have to be able to interpret a sign chart. The thing is that that is the final step in solving the problem. Okay, the final step is answering the question or interpreting your sign chart. Now let's look at the beginning. Okay, so I wanted you guys to have some experience with that, because otherwise there's a lot of steps to this, and then when you get to the end, you're like, okay, what do I do now? All right, so let's start at the beginning. All right, so let's look at this problem here. So solve x over x minus 1 less than or equal to negative 2 over x minus 1. So on the left-hand side, I'm going to outline the steps. Okay, so number one is you want to add or subtract to get all terms on one side of the inequality. So you want your stuff, let me call it, yeah, stuff. I want it to be either greater, like less than 0, or I want something like this. I want 0 on one side. Usually I put it on the right side just because that's, you know, it's easier to read left to right. Okay. So that means we're in this problem. I'm going to take this and I'm going to add. And I'm kind of going like straight across just because it seems to make a little more sense here. But I'm going to add that 2 over x minus 1 to both sides. So this is my step 1. Okay. And then what is that going to give me? Well, these are the same denominators, so I can just put these together over x minus 1. And on the right side, negative 2 plus 2 is just going to be 0. So is everybody okay with that? Everybody see how we did that? I got 0 on the right side. Okay. Now, what I've given you up until this point is I've said, here's my function, and now here's the graph. Well, we're not going to have the graph to look at, okay? We don't need the graph because we can do the sign chart without it, okay? So we're going to create a sign chart. Without using the graph. Just the function is all we need. Okay. And I mean, again, remember mathematics is about trying to get to the end as succinctly as possible. So if you don't need to graph it, that's a lot of extra work you don't need to do. All right. So number 2, what do we do next? All right. Well, I'm going to put in here, combine all terms into one fraction. But that's already done for us. This part step 2 is done. All right, we already have it in one fraction. All right, step 3. Now we need, yes, very good, Marianne. Find the zeros and find the undefines. Okay. So for step 3, I'm going to take this and I'm going to write it as a function. And in fact, one of the things I want you to do is just kind of like block this off. You're going to need to look at this later. Okay. But you do not operate on that inequality. Okay, you cannot, I want to stress this, you cannot multiply both sides by x minus 1 across an inequality. Across an equal sign, yes. Across an inequality, no. So let's, I want to explain that in a minute, but let's go through this process first and I'll come back and tell you why you cannot do that, because that's really important. And if you do it, you automatically get 0 points on the problem. So you can't do it because mathematically it's very wrong. And you also can't do it because it automatically cancels out any points you get for this. Okay. So I'm going to write it as a function. So write this as a function. And now to find the zeros, so I'm going to say zeros. Remember, if you want to find the zeros, that's the same as your x-intercepts. Well, how do we find the x-intercepts? We set our function equal to 0. Remember, we've done that many, many times. So I'm going to take my function x plus 2 over x minus 1, and I'm going to set it equal to 0. Now that it's an equation, it's okay to multiply by that x minus 1. In an equation, you can do that. So x minus 1 times this fraction ends up, this is a 1, and I get x plus 2 is equal to 0. And then this is just a nice little linear equation to solve. We've done this lots of times. X is -2. So that's a 0. What this means is the graph crosses the x-axis at x equals -2. Okay? So if you had to get an image in your head, that's my 0. My graph is either coming through from above to bottom, or it's coming from the bottom to the top, but it's coming across that x-axis. Okay? Now, the undefines is easier than this. Where is this function going to be undefined? Yeah, Marian's got it in the chat. It's wherever your denominator equals 0. So if I have x minus 1, it cannot equal 0, so my x cannot equal 1. Okay, so the image in your head for the either your graph is crossing like this at -2. Okay, that graph is crossing or like this. So my graph is crossing the x-axis. But for the undefined, your image in your head here should be this is an asymptote at 1. Oh, it's all like jumbled up. Okay. So you guys see that? So I don't need to graph that to know that. I know that my zeros means crossing the x-axis and that the graph is undefined. Okay. So once we have those, so next step, step 4, is we're going to place the zeros and undefines on a number line. So here's 4. And all I have is 2 numbers to put on there. I have 1, which is bad, and -2, which is a 0. So this is there, this is not, okay? And I like putting an open circle on the bad numbers, because then when you go to write your intervals, that should stick out to you that you cannot include it, not ever. The zeros, you have to be more careful. Yes, Marianne, you should teach this class for me. I could have slept in today. All right, so now we're gonna do something called test regions, test intervals, or regions, okay? And we have 3 of them here, okay? I have this one from -∞ to -2. I have this interval from -2 to 1, and I have 1 to infinity. And your graph can only cross the axis at either a 0 or a bad number. So if I pick a number in any of those regions, that will tell me where my graph is at. Is it going to be above the x-axis or below the x-axis? If it's above, then my outputs are positive. If it's below, then my outputs are negative. Okay, so now let's do that. Here's 5. So choose a number in each interval, but not the endpoints. So I can't pick -2. -2 is just going to give me 0. So it's not helpful. So here's region 1. So f of x equals, my function was x plus 2 over x minus 1. Okay. So I'm going to choose an x that comes before -2. And the easiest one is probably -3. So we don't get super creative here. You can if you want to. I mean, you can pick a decimal or fraction, but nobody likes to. But as long as it's before -2. So like, I'm going to pick something like -3. And then we're going to plug it in. So f of -3 is -3 plus 2 over -3 minus 1. And this is going to be -1 over -4, which turns out positive. Negative over negative is positive. So in the region before -2, this is positive. Okay. All right, region 2. Again, I use the same function. What do you guys want to plug in between -2 and 1? I hope you're all saying 0. Anytime you can use 0, it's always like, yes, I can plug in 0. Okay, so f of 0 is 0 plus 2 over 0 minus 1, which is 2 over -1, which is -2. All right, so that means my outputs between -2 and 1 are negative. All right, last one. I'm going to squeeze it in over here. Region 3, I'm going to pick something bigger than 1, so just going to pick 2. So f of 2 is going to be 2 plus 2 over 2 minus 1, which is 4 over 1, which is positive. Okay. And now we have our sign chart. I didn't even have to graph it, see? But I know that whatever is happening before -2, the graph is above the x-axis. Between -2 and 1, it's below. And then after 1, it goes back up. Okay, so that should kind of be like your mental picture of whatever those things look like. All right, so now the last step is answer the question. And you're going to be like, this is what I'm talking about. You're going to be like, what was I doing again? Remember that inequality I boxed in up here? Yeah, this is my question. My question is asking, when is x plus 2 over x minus 1 less than or equal to 0? So let's write that down here. So x plus 2 over x minus 1 less than or equal to 0. This is what we need to solve. It's not, I'm saying solve this. Okay, is everybody, any questions about that? All right, so what's my answer? When is this less than 0? Which region do we pick?
Region 2.
Yeah, region 2, from -2 to 1. Now, do I include -2? Let me look. This does include zeros, right? Because there's an equals.
Mhm.
Include zeros. So -2 is included. But 1 is not, because you never include bad numbers. And that is the answer. After all of that, that is the final answer. So we solved the inequality. We found when the outputs are going to be less than or equal to 0. It's a lot of steps. See what I'm saying? All right, so just let's quickly review. Let's go through everything. I like to do that because we did a lot of stuff here, okay? So we started out with this function that had parts on both sides. Added it so that we got everything on one side and it became a fraction. And then this is the question we want to answer right here. Okay. When is the function going to be less than or equal to 0? All right. So then we went to work, made it into a function, found our zeros, and found the bad number, which was 2 and -1. Put them on the sign chart. And then you test regions by plugging in numbers in each region. Once you know where it's positive and negative, then you can finally answer the question. And you know that it's all the numbers from -2 to 1, not including 1. Any questions? It's a lot of stuff. Huh? All right, so where am I at on time? I have a little bit of time. Let's do one that's not a fraction. Tomorrow I will do more of that. So let's do one like this. Maybe I have time to get through this one. So here's example 2. Solve x to the third plus 8x squared plus 16x greater than 0. All right. So we're already lucky. It's everything is on one side. So step 1 is done. We have it greater than 0. Okay, we don't need to like add or subtract. That's good. So now step 2 is going to be finding your zeros. We don't have any fractions to put together and my bad numbers. Okay. So I'm going to set this, make it a function. So we can box in like right from the get here, right from the start, we have our question. It's already set for us. That's nice. Okay, don't ever say I didn't do anything good for you. Yeah, right. Okay. So now I just make it a function, x cubed plus 8x squared plus 16x. And to find our zeros, what do we need to do? Any ideas? Factor. Yes. So first I'm going to say, so my zeros, I'm going to find my zeros. I want to make y equal to 0. So let's first set this equal to 0. Yes. So this is x cubed plus 8x squared plus 16x. And then we're going to factor, right? So I'm going to factor out my common term of x. And we have x squared plus 8x plus 16. And then also, because I don't want to complicate this with quadratic formula, this does factor. Yes, it's going to be x times x plus 4 times x plus 4, which is 0 is equal to x times x plus 4 squared. All of that is true. Now, I still have to find the 0. So remember, this is x is equal to 0 and x plus 4 is equal to 0. And so x is -4. So here's my 2 zeros. Okay. And then let's look at our bad numbers or undefines. Where will this function have numbers I can't put in it or break it? Okay, let's review when that happens. we have denominators equal to 0, or roots, even roots have to stay positive. So far, those are our domain restrictions. Exactly. This is all real numbers work. There are none. So that is happy day, okay? No bad numbers. Polynomials have domains that are all reals, no restrictions. Okay. So next is we're going to make our sign chart. Now that we have that information, we can put everything on a number line. And all I have to put on here is -4 and 0. And they're both zeros. They're both included. The only thing is, if I look at my problem, okay, you see that even though the zeros are just zeros, they're not included because of that. So what we could do, if we wanted to be careful, you could automatically just go ahead and put open circles there, because or how about nothing? That's dangerous because I don't want you to think they're bad numbers. I don't know. What do I normally do? Oh, in my notes, I did make them open circles. These are not included. But put a little Z on top so it says they're zeros. Yep. So open circle, like, it just kind of puts it in your mind that those are not included. All right, so region 1, region 2, region 3. I have to plug stuff in. It is easier to plug it into the factored form. Okay. So here's region 1. I'm going to pick X is -5, something before -4. So that means f of -5 is -5 times -5 plus 1. That's -5 times -4 squared, which is -5 times 16. Now, I know because I've multiplied this a million times, this is -80, but you should just see right away that this is going to be negative, right? If I have a negative times a positive, it's negative. Okay. Here's region 2. I picked something between -4 and 0. So I don't know, let's do -1. So f of -1 is -1 times -1 plus 4 squared, which is -1 times -1 plus 4 is a +3 squared, which is -1 times 9. This is also negative. All right, region 3. Let's pick something bigger than 0. I'm just going to pick 1. So f of 1 is 1 times 1 plus 4 squared, which is 1 times 5 squared, which is 25. That's positive. Okay. All right, what's our last step? Now that we have our sign charts, negative, negative, positive.
Answer the question.
Answer the question. So 4, answer the question. So we had, it was x cubed plus 8x squared plus 16x. So x cubed plus 8x squared plus 16x. We want to know when this is greater than 0. So we're going to solve this finally. So what do we put?
Region 3?
Yeah, it's region 3. So it's greater than 0 when it's positive. So that's 0 to infinity. And neither of these are included because it's strictly greater than. Any questions? Okay, I'm slightly over. Good job hanging with me. We'll do some more tomorrow, and I will see you then. Bye, everybody.
Thank you.
Have a good day.
Goodbye.
Oh, let me stop recording.